This is Bhuvaneshwari, Assistant Professor, Department of Mathematics from St. Joseph College, Hosur. In this session, we'll discuss about how to solve the differential equation using Laplace transform. So, an equation containing y, this is the first derivative of y dy by dt, and its second derivative is d square y by dt square. So, an equation containing a function, its first derivative and second derivative. Function and its derivatives is called as differential equation. In this session, you're going to see how to solve this type of differential equation using Laplace transform here. So for that, first we need these two formulas. Laplace transform of dy by dt. L of dy by dt is equal to L of y dash, first derivative of y, which is nothing but s L of y minus y of 0. L of d square y by dt square is equal to L of y double dash is equal to s square L of y minus s y of 0 minus y dash of 0. So first shall move on to the problem. So you are going to solve this problem. D square y by dt square plus 5 dy by dt plus 6y is equal to e power t. The initial conditions are given. Y of 0 is equal to 0. That means the function y's value at the point 0 is 0. First derivative of y at the point 0. Its value is 1 here. So first I am rewriting the equation as d square y by dt square means it's nothing but y double dash y second derivatives y double dash plus 5. This is the first derivative. So 5y dash plus 6y is equal to e power t. So we are applying Laplace transform on both sides here. So Laplace of left-hand side term is equal to Laplace L of e power t. So I am applying Laplace for each term. L of y double dash plus 5L of y plus 6L of y is equal to, we know the formula for L of e power at is 1 by s minus a. So in the place of a, you're having here 1. So e power 1t means 1 by s minus 1. So instead of L of e power t, we are writing here 1 by s minus 1. So next step, instead of L of y double dash, we are going to solve this formula here. And same way, L of y dash also, we are going to substitute this formula here. So we will get as s square L of y minus sy of 0 minus y dash of 0 plus 5s L of y minus y of 0. Other two terms will get as it is 6L of y is equal to 1 by s minus 1. So we know that from the initial condition, y of 0 is equal to 0, given condition. From the question, it is given y of 0 is 0 and y dash of 0 is equal to 1. So instead of y of 0, 0, substitute 0. I dash of 0. Instead of y dash of 0, substitute 1. In the place of y of 0, substitute 0. Other terms, I am writing this as it is here. So we will get as s square L of y minus s into 0 is 0 minus 1 plus 5s L of y minus 0. So I am leaving this term. The 6L of y is equal to 1 by s minus 1. So in this term, from the first term, we can write minus 0 minus 1. I can write this term as s square L of y minus 1 here. So here L of y, L of y, L of y. In these three terms, L of y is common. So I am taking it commonly outside. L of y is equal to the remaining will be s square here. If I take L of y commonly outside, the remaining is 5s here. If I take L of y outside here, remaining is 6. So s square plus 5s plus 6 we will get. Remaining minus 1 is there. We'll get here minus 1. When I take this minus 1 to right side, we will get 1 by s minus 1 plus 1 here. So we are taking LCM on the left hand side, writing as it is. Right side I'm taking LCM. So s minus 1. Cross multiplying, we'll get 1 plus s minus 1 by s minus 1. Minus 1 plus 1 get cancelled. So we'll get s by s minus 1 here. So L of y is equal to s by s minus 1. This term will come to the denominator as s minus 1 into s square plus 5s plus 6. So we need to first solve means we are going to find the value of y here. So from L of y, we want to find the value of y. Y is equal to L inverse of s by y is equal to, when I take L to the side, we will get L inverse of s by s minus 1 into s square plus 5s plus 6. So I am taking only the term inside the bracket and I am simplifying it. So s by s minus 1 into factorizing this term, s square plus 5s plus 6. what two terms should be multiplied to get 6, and those two terms when we add we should get 5. What are the two terms? 2 and 3. S plus 2 into S plus 3. When I multiply these two, I'll get 6. When I add 2 and 3, I'll get 5. So I can write S square plus 5S plus 6 as S plus 2 into S plus 3 here. So I'm taking this term S by S minus 1, S plus 2, S plus 3. I'm splitting this using partial fraction as A by S minus 1 plus B by S plus 2 plus C by S plus 3. So I can write this term as, write the left term as it is, right hand side, taking LCM, I will get S minus 1, S plus 2, S plus 3. What are the terms missing in this term? The denominator, S plus 2, S plus 3, multiplied with A by S plus 2, S plus 3. What are the terms missing here? S minus 1, S plus 3. Multiply B with S minus 1, S plus 3. What are the terms missing? S minus 1, S plus 2. Multiply C with S minus 1 and S plus 2. So we'll get the equation like this. Denominator, both the terms are same. S minus 1, S plus 2, S plus 3. S plus 2, S plus 3. So these two get cancelled. So we will get an equation like this. Take this as equation number 2 and this as equation number 1. So when next step we are going to find the value of A, B and C, and we are going to substitute in this. So first, when I put S is equal to minus 2 means in the place of S minus 2, this becomes 0. Minus 2 plus 2, 0. Minus 2 plus 2, 0. So first I'm going to substitute S is equal to minus 2 in this equation. So minus 2 is equal to 0 plus minus 2 minus 1, minus 2 plus 3 plus 0. These two terms become 0 and we will get only B. So S minus 1. So minus 2 minus 1 minus 3. S plus 3. S is minus 2 plus 3 is plus 1. So minus 3 into 1 is minus 3B is equal to minus 2. So B is equal to minus 3 by minus 2. So B is equal to minus 2 by minus 3. So minus minus get cancelled. So we'll get as B is equal to 2 by 3 here. Same way, we can substitute S is equal to minus 3 in equation 2. If I substitute means A and B gets 0. And C term, S is equal to minus 3. So minus 3, A and B becomes 0. C into S minus 1, S plus 2. In the place of S, put minus 3 minus 1. S plus 2 means minus 3 plus 2. Minus 3 minus 1 is minus 4. Minus 3 plus 2 is minus 1. So when I multiply, you will get minus 4 into minus 1 is 4 into C. 4C is equal to minus 3 is equal to 4C. So C is equal to minus 3 by 4. That is the value of C here. Next, we substitute S is equal to 1 in equation 2. We will get 1 is equal to S is equal to 1. So A into B and C becomes 0. A into S plus 2, S plus 3. S is equal to 1. So 1 plus 2, S plus 3 is 1 plus 3. So 1 plus 2, 3. 1 plus 3, 4. So 3 into 4 is 12. 12A is equal to 1. So we'll get A's value as 1 by 12. So we got A is equal to 1 by 12, B is equal to 2 by 3, and C is equal to minus 3 by 4. We are substituting this equation, these ABC constants in equation 1. Is A by S minus 1 plus B by S plus 2 plus C by S plus 3. So L inverse of A by S minus 1 means, A I am writing it as A means 1 by 12 I am writing by S minus 1 plus 2 by 3 S plus 2 minus 3 by 4 C by S plus 3 minus 3 by 4 S plus 3. Next I am applying Laplace for each and every term. L inverse of first term, L inverse of second term, L inverse of third term. So when I applying Laplace, 1 by 12 is constant. So I am taking 1 by 12 constant outside L inverse. So we'll get 1 by 12 into L inverse of 1 by S minus 1. 2 by 3 constant. So I am taking it outside. So 2 by 3 L inverse of 1 by S plus 2. Minus 3 by 4 is constant. So I am taking it outside. 3 by 4 L inverse of 1 by S plus 3. So we know the formula for L inverse. L inverse of 1 by S minus A means e power 80. Minus A means e power 80. Same way, similar way, S minus 1 means e power 1t. That is e power. In the place of A, you are having here 1. So S minus 1 is equal to e power 1t. Next is L inverse of 1 by S plus 2. L inverse of 1 by S plus A means e power minus 80. So e power, here S plus 2 means e power minus 2t. Here plus A means here minus 80. So here plus 2 means e power minus 2t. Same way here S plus 3 means e power minus 3t, minus 3 by 4 e power minus 3. So we finally we got the answer for y. Thank you.